Thank you, Damian, again, and everybody who came, both directly to this room or to the wrong room before coming here. My deepest apologies if I have circulated the wrong link. I owe all of you coffee and cookies, biscuits next time we meet, which I hope will be sooner than later. The title, as has already been announced, has this exclamation mark. It's like gluts and gaps prevail. There's more to it. Let one thing contradict another, and let one slide of my talk contradict another. Please, any resemblance to an actual poem by Walt Whitman is not purely coincidental. I go to the slides. So there is some, okay, there's some lag in between me changing the slides here and they appearing there. Oh, that was a long lag. So let me just start with arguments. Logic is about arguments. Some of you might know this sketch, if someone comes, J for John. Now let's get one thing quite clear. I most definitely told you. Oh no, you didn't. Oh yes, I did. Oh no, you didn't. Oh yes, I did. And this goes on, and until the man says, oh look, this isn't an argument. Yes, it is. No, it isn't. It's just contradiction. No, it isn't. Now, you know, the contradictions are sometimes unavoidable, and this sketch is to remind you that you might even be paying for it in the argument clinic. Now, what I want to bring to your attention here is this very nice philosophical set that was in a paper by Damon Young, I think from Melbourne, and Graham Priest 4 years ago, in which they, in explaining what dialetheia is, they write something like the point being that you have I being P and not being P at the same time. I like to put it this way, in which we don't decide that P is the predicate being true, because it's probably even better put this or explained this way, that the dialetheia need not be about truth. But they do need to be about this, this apparent confusion in between I is P and I isn't P. Most people will agree that there is probably something wrong there. Now, they might not agree on who's to blame. Is it the object which falls under the extension of the predicate and at the same time doesn't? Or is it the predicate which has this dubious extension containing and not containing the object? Now, the paraconsistent logician will say that the problem is actually somewhere else. The problem is in the not, in isn't. And not being represented by negation, he will say that negation fails to be a contrary forming operator. I know that not every paraconsistent logician would put it this way, but by putting it this way, we're just saying that it's not an operator that is such that forbids a sentence and its negation to be at the same time true, while a contrary forming operator would forbid just that. Now, just to give an example of how this comes about, and this is the example that Graham Priest used on his 1979 paper, was the logic LP, three-valued logic, which could be presented this way in terms of logical matrix. I'm cheating a little bit in the presentation of a matrix, because in the literature, the logical matrix actually doesn't have just a set of truth values, but an algebra of truth values. And the semantics is produced by the set of homomorphisms in between the language and this algebra of truth values. But let's just consider that we have three truth values. Besides the false and the true, we have this B, intermediate truth value, and we consider, as in any logical matrix, a set of designated values containing, in this case, the true, but also this B. You can read both if you want. So the matrices for the language, which contains basically negation, conjunction, and disjunction, is this one that you see over there. And one obvious thing that comes to our view when we just look at it is that there's something funny happening with negation. Both a formula and negation can be designated or true in a given valuation. Actually, this is even worse. It's much, much worse, because if you take all the prepositional variables and give them the value B, you can easily see that this is contaminating the logic. You have negation of B is B, B combined with B through conjunction or disjunction gives you B. So in that case, you would have a valuation, you would have an interpretation that gives the value B, a designated value, to all the formulas and not just to one formula and its negation. I call that a Dadaistic valuation. It doesn't make any difference in between being true. Everything is true. Everything is just as good. Now, to go into from the logic to dialectism, which seems to be about trying to sell a true contradiction. Let me just mention a couple of versions of the entry, the Stanford Encyclopedia's entry on dialectism. I put in bold here, and some of them also in blue, those in which there were substantial modifications in the definition of, or in the entry, the text of the entry. And I just wanted to mention at this point that everything flows, as you know, but some changes were really substantial, as I'm going to show, as I'm trying to make this history of what dialectism could mean. And in particular, in the first 10 to 11 years of existence of this entry, you had only one author, and then in 2008, Graham Priest welcomed Franz Berto, also as an author. And Berto is the one who has actually written the book on how to sell a contradiction. And I'm here pushing the problem of how to sell a true contradiction. Now, let me just mention some very short passages from these entries. So the first version of the entry for the first 10 to 11 years of existence, it started by saying that adelethea is a true contradiction, and explained that by that it was meant that it was a statement such that both it and its negation, is not just a negation, but the negation, are true. And from that concluded that dialectism was the view that there are true contradictions. Now, sometime later, this changed quite a bit. So first of all, let me just notice that in this new version of the entry, starting in 2008, very far under, like in section 3.2, gluts are mentioned for the first time. Before that, gluts had not been mentioned in the entry. But now dialecthea is no longer called a true contradiction directly, but it's called a sentence in such that something happens to it. And it also says that it assumes a fairly uncontroversial view that falsity is just the truth of negation. And I admit that this is very uncontroversial from the point of view of an intuitionist, but maybe not for a paraconsistent logician. And it says that one can define a contradiction as such and such, and only after that concludes that that dialectism is about the true contradiction. So after defining contradiction as a couple of sentences, such and such. And even the notion of falsity has just been defined as being the truth of negation, which had not happened before. Now let me just put this, keep this over there and show you the next modification, which is really important, 2018. Now, it starts the same way, but gluts have been promoted. You see that right at the beginning of the entrance, of the entry already, gluts and gaps are mentioned already at the first paragraph of the entry. Now, there are some interesting, maybe we could call them word games happening here. You see that this version of the entry says that if falsity is assumed to be, and if we define a contradiction as, then you can say that dialectism amounts to the claim that there are true contradictions. So it's like if we redefine all this, then we can say that. I cannot fail to recall the anecdote by, it's attributed to Abraham Lincoln, of when one asks, how many legs does a dog have if you call his tail a leg? Now, I tried this on my 4-year-old this week, and she had no doubt she got the right answer. I will not tell you what that answer is, but some of my students didn't. Okay, so as soon as we are having some uncontroversial assumptions, I will just push some of my own assumptions for the talk. and tell you what I intend to be speaking about. Now, first of all, I want to move this slide. Yes. I have trouble to understand when you talk about truth if you don't relativize it to a model. So for me in the talk, it will always be, when I say that something is true, it's always true in terms of satisfaction, so truth in a model. The other thing that I have to warn you about is that I will in general assume that paraconsistency is more than just having a model for a formula and its negation. So if, for instance, this model which makes all the formulas true is not a very good one to justify a paraconsistent logic. In fact, if you take any consistent logic and add a valuation that makes all the formulas true, you don't change the Tarskian consequence relation defined from it. So adding a valuation that makes everything true doesn't make anything become false. So you introduce no counter models. Everything that was true before is still true, and vice versa. Now, this is just an instance of a much more general phenomenon that has been studied since Carnap. Lloyd Humberstone calls it a conjunctive combination of valuations. I don't know if the name was promoted by him, I think so. And it's the idea that whenever you have a set of valuations and you define a new valuation, and by making the formulas true if and only if all the other valuations in the set agree in making that formula true and false otherwise, that new valuation doesn't introduce new counter models. That change the Tarskian consequence relation behind a given logic. So it's a conjunctive combination of valuations. Another thing that you should take into consideration, that I'm talking about avoiding models that make everything true. I will not enter into the issue here, but we of course want to avoid models that make every thing equally true. So that assuming that all contradictions might hold, this will not even be an issue for us here. And I'm not judging about the world, I'm judging just about the logics. The logics we'll be talking about will not consider that possibility. Now, the other thing that I wanted to introduce is that the very idea of talking about glutty reasoning is not something that concerns negation. At least I will try to convince you of that. So that when I'm talking about allowing gluts and allowing gaps into the logic, so in such a way that the certain classical meta principles or principles, logical principles are denied, this is actually something that happens at the level of consequence, something that happens at the metalogical level, and we do not and should not use connectives to express these particular kinds of logical principles, as I will try to convince you later on. Now, just to go into the talk itself, it would be very, very easy if I wanted to present to you a semantics that had gaps or gluts in it. If a semantics is a set of valuations, so a valuation that has a gap is basically a function from the set of formulas into your truth values that is partial. And one which had gluts would be a function which is not a function, it's non-deterministic, it's a relation. I will not consider that. All the valuations and all the semantics that will appear in this talk are made of total functions all the way. And what I will do in the next 3 sections will be to, first of all, introduce a certain notion of judgment compatibility, from which I will redefine the notion of consequence that you all know. Then I will extend this notion of judgment compatibility to what I call a bilateralist approach to a consequence. So I will add a further dimension, and I will stop talking about assertions and denials, and we'll talk about what I call cognitive attitudes. And then I will illustrate how this could be used to define a plethora of logic, so many different perspectives into what consequence could be. I will purposefully not enter into all the details, and there are some things that I have promised and will be omitted in the talk. Please ask about them at the end if you're interested. Okay, so these were the principles that I will be taking into consideration, and let me enter then this idea that logic is an analysis of sentences and arguments, and it involves passing judgments on them. Now, just to fix some notation, I will use S for the set of sentences. S is actually not for sentences, it's for Sprache, for language in German, but doesn't matter. And what I will call a consecution, some people call them sequence, but I will reserve that for proof theoretical investigations, which I will actually not do here. And just a pair of sets of sentences. Let me see, show you what I'm gonna do with them. So let me assume for the moment that I'm going to introduce a certain relation in between pairs of sets of formulas, and I call this relation judgment compatibility relation. I will assume about it the following three things. First of all, if you have something called a valid judgment configuration, so which will be constituted about consecutions and judgments upon these consecutions. If you have a fragment of such a valid judgment configuration, it will also be valid. Also, that at this moment I will disallow gluts and gaps on judgments. Now, one way of making this into something mathematical would be writing some metalogical principles or axioms, meta-axioms on the relation, such as the ones right here, which should appear, but do not. Okay, there is a serious lag here because, oh yes, they appear, yes, there they are. Don't look at them too seriously now, just notice that they are, and they concern this dark triangle, which I will explain better in the next slide. Okay, so this will come back. The idea is that this black triangle will represent a way of saying that a certain consecution is a valid judgment configuration, and I will just write it in this usual infix notation. Now, what do I mean by compatibility here? Actually, I'm inspired by Bolzano, but I will not enter very much into that at the moment. Let's just take the very common approach, which has been used by a lot of people working on multiple conclusion approaches to logic in talking about assertions and denials. I'll take them as primitive judgments at the moment. And what I want to say about them is that, well, here is a way of reading that judgment configuration, valid judgment configuration that I presented in the previous slide. I will read this as saying that somehow the sentences in the left-hand side, delta 1, may be asserted, while those on the right-hand side, delta 0, are denied. So it's about the compatibility between these two acts, if you want, of asserting delta 1 and denying delta 0. I do not want to enter into the merit of who is doing that act. I will just use this indeterminate subject at the moment. Now, if I just want then to repeat what was in the previous slide and read it out loud for you in terms of assertions and denials, the first metalogical principle says that, well, if pi together with pi prime may be asserted, while sigma together with sigma prime are denied, so in particular, pi may be asserted and sigma is denied. So this is what that was the fragment, what I meant by fragment of a certain configuration in the previous slide. The second one, if you read it literally, it just says that, well, if you pi may be asserted and sigma may is denied, then they cannot have anything in common. So in particular, there may be no formula which is simultaneously asserted and denied. And the third one says that, well, when you have such a context of assertions and denials, and then you have a new set of formulas delta, there must be a way of partitioning or quasi-partitioning that set of formulas in such a way that some of them go to the left and some of them go to the right. The other ones go to the right. So in particular from that, also you may conclude that you have a certain sort of logical principle. I'll just put both here. CM1 in particular, if you have pi and sigma both being a singletons of phi, it asserts this general metalogical version of the principle of non-contradiction that I write here by saying, which says that no sentence is to be simultaneously asserted and denied. While the CM2, as I said, in a particular case where delta prime is a set which is a singleton, is saying that, well, that formula inside that set must go either to the left or to the right. And this is a way of saying that it must be either asserted or denied. You do not need to agree with these principles. What I want to convince you is that actually they are already present in things that we work on a daily basis. But what I did right now, and I want to call attention, is that I just formulated a version of the principle of non-contradiction, the principle of excluded middle, which do not involve any connective. In particular, does not involve negation. And that's worth considering, among other things. Now, just to show you that you might have already seen all this in some certain different format, what I'm going to do now is that from this black triangle, I'm going to take the set-theoretic complement, which will be a white triangle. And what I'm going to do with these sentences here is I'll just read them contrapositively. So if you look at the first one and I transform it into this, you will see that it looks like something you might agree in terms of consequence. If sigma follows from pi, then sigma plus something else follows from pi plus something else. The other one, if you look at contrapositively again, if there is anything that belongs to both sets, then that thing follows from itself. And the third one, it's a bit more difficult to see how it corresponds to this, but if you check, this is what it's going to be. It clearly looks like something is being cut, something is disappearing from the antecedent of the if to the consequent of the if. Now, you might recognize this already as a sort of approach to consequence, which has been championed by people like Dana Scott, Shoesmith, and Smiley. And you see the S consequence relation that I put there to remind us of this origin. As this is the complement of the other notion of consequence, which I call judgment compatibility, I might just call it judgment incompatibility now, or multiple conclusion consequence relation on set, generalized consequence relation. There are many names for this. I prefer to call it bilateralist notion of consequence, as I will explain in a moment. Now, just to give an example of what you can do with it, a lot of stuff. One of the things is that you might just consider in a language containing an arrow, the least consequence relation, which respects the above axioms, and the three further sequence or consecutions or valid configurations. I might just read this as being zero premise sequent to sequent rules, or axiomatic sequence, as I prefer. These three things together actually determine that we are talking about something that behaves like classical implications. Now, if you're an intuitionist, don't worry, you will not just avoid looking at this third axiomatic sequence over here. Well, not just because you need to put something else, but this is certainly something you don't want to consider. Now, if you still have not recognized something that you know, I'll just go one further step, going from the bilateralist approach to the unilateralist approach. And this is something you should certainly be able to recognize, which is that a T consequence relation, now instead of a set of formulas on the right, I consider just one formula on the right. If I just do that restriction, the same principles we saw before actually turn out to be expressible in these three sentences. And you might even know this sentence by some abbreviations like M, R, and T, which people would often refer to as monotonicity, reflexivity, and transitivity. Now, so the way we arrived here was starting from this compatibility relation, then taking its complement, which was an S consequence relation, then taking a particular case, which was the T consequence relation, or Tarskian consequence relation, which I have already mentioned at the beginning. So first of all, I want to make it clear that they are connected. It's in particular, Tarskian and T consequence relation, S consequence relation are very obviously connected in the sense that you can look at an S consequence relation and focus in one aspect of it. And then you're going to see that inside an S consequence relation lives one and actually many T consequence relations. In particular, you could just fix the right-hand side to contain a singleton, and that defines a consequence relation, which I will call the purely assertion-based T-consequence. So you start with the generalized notion of consequence, and you define this unilateralist notion of consequence. You can also define it the other way around. You can start by fixing a singleton on the left-hand side, and you have a sort of purely denial-based T-consequence. These things are usually read in terms of preservation of warrant, commitment to asserting on the first case, and on the second case as preservation of this warrant or commitment to deny. Now, the other way around is not that obvious. If you have a T-consequence relation, there are many, in general, as consequence counterparts to it. So this is, there is no deterministic way of going from T-consequence to as consequence. It's, the bilateralist framework is legitimately more expressive than the unilateralist framework, and not just easier to use. Now, let me open here a parenthesis to talk about this notion of logical theory that could take advantage of this bilateralist approach, and which I think very few people have actually used. So imagine that now I can present a theory by having both axioms and anti-axioms. So intuitively, the axioms are the things which I'm not going to question and I'm willing to assert, and the anti-axioms I'm also not willing to question but, and willing to deny. Now, one thing you can do with them, and actually has been done already by, or proposed and suggested by people like Haskell Curry in the 50s, is that you could define for every set sigma here of background denied sentences, sentences that we agree that should be denied for some reason, you can define an operator which has all the properties of the Tarskian closure operator, and from which you can define a Tarskian consequence relation as the one we saw in the previous slide, which in a sense could be understood as being the set of theorems, the set of theorems here, which are to be deduced, to be concluded from the axioms in gamma 1, given the background denied sentences in sigma. And in the same way, or the other way around, you can look at the set of anti-theorems of a theory anti-axiomatized by a set of formulas gamma 0, given a set of background asserted sentences. So what I said in the previous slide is that there was at least two Tarskian consequence relations which could be associated to every S consequence relation. And now I'm saying that there is an enormous number of consequence relations. For each choice of sigma and p and pi, there is, in principle, different notion of consequence to be associated. If sigma and pi are empty, we're back to the examples from the previous slide. Now, what can we do with that? A very interesting thing. If you start in a theory which contains a set of axioms pi and contains a set of anti-axioms sigma, you can define a new operation, which is an operation which receives this pair of sets of sentences and gives you a pair of sets of sentences which could be claimed to be precisely the closure of that by theory containing pi and sigma. Now, this might be trivial and it's easy to check, but what I wanted to mention here is actually that if instead of defining it like this, if I now want to look at the axioms, the metalogical axioms, which will be respected by anything which happens to be defined like this, I'm looking towards a generalization of as consequence, which receives not just a set of formulas, but a pair of sets of formulas. Okay, that has been done. And it can be done. The axioms that come out of it are similar to the Tarskian axioms, but very surprisingly, there is a new axiom which concerns the interaction between axioms and anti-axioms, or theorems and anti-theorems. So this axiomatization of this bilateralist notion of consequence, which comes from this two-dimensional closure operator that I just presented here, is to be found in a paper of ours, which is going to be soon published at Synthèse. I could give more details if you're interested, but I just wanted to say that there is work to be done there, and that notion of logical theory is not well known as people think it is. Now, I pass now from to this generalization. You might have thought that I was already generalizing, but I was just doing the unilateralist approach with in the framework set rather than set formula. Now, I do want to go a little bit beyond that. And how can we do that? Let me make an analogy. First of all, let me just ask about where do these things, truth and falsity, come from. I took this, the title from this slide from the book by Wanzig and Schranko, in which they talk about, this is probably the end of German idealism at the end of 19th century, in which people were really interested in the beauty, the good, the truth. While, for instance, nowadays, people in ethics would be more interested in better than the good. What I wanted to mention here is that actually I'm not so much committed to the truth and the falsity as I am committed to consequence, but I can use them. And I'm going to arrive to them through assertions and denials. So let me just try to explain that these both these notions of consequence can be explained, as I said before, using logical matrices, using designated values and their complements, so-called undesignated values. And one simple thing that could be done to see that these sets of values actually did not really need to contain many truth values, but could contain only two logical values, was proposed by Roman Sushko in his Sushko's thesis, which has a technical counterpart, which is the Sushko's reduction, which is the following. You take the homomorphisms here in between the set of formulas into the truth values, and then you flatten them up. You take all the designated values to the true, all the undesignated values to the false, and in that case, you can just compose these two functions and build another one. Now, these are the functions that I just built here by composition. It's not necessarily a homomorphism in between the set of formulas and the new set of values, but it doesn't really matter because you can easily prove that using only them, you can define sound and complete semantics to the same logic. So you define the same notion of consequence using only what I call bivaluations, valuations that use only two logical values. So, and Sushko's point was that the whole invention of many-valued logic was humbug, was something that was a farce that persisted for too long, and that these many logical values were just some algebraic invention, and that subsiding them, there were only two logical values. So truth values in one side and logical values on the other side. So this is not to be questioned because it's just a technical result, very simple. But it's one thing that might make you think, okay, so this guy is mapping all different kinds of assertions in the set of designated values into the true, all different kinds of denials into the false. So why and how come he wants to talk about other logical values such as the glut or the gap? So I need to explain to you where these logical values come from. So I proceed to do that, just that. And the idea here will be to allow for what I call glutty reasoning and gappy reasoning. Remember that I have mentioned before that gluts and gaps were disallowed by axioms, which said that things could not be asserted and denied at the same time, or that things needed to be either asserted or denied. So a very simple idea one might have here is that, okay, throw those axioms away. If you want to allow for them, you cannot have those axioms. And actually one can prove, and we have done in a paper with Heinrich Wanzig and Carolina Blasio 3 years ago, that this is precisely what happens. When you throw one of those axioms away, you get a new version of this reduction in which you need more than two logical values and might be 3 or 4 logical values. I'll go into it, but just wanted to mention that here, I want to change a little bit the talk to talk about information, not about truth or assertions or denials. And let me assume that information is something that's out there, that is really an existing thing. I just read last week on a BBC Nature, they had an interesting website in which they showed that Mark Zuckerberg's body contains 800 megabytes of information. So apparently it's a very objective thing, right? They're probably measuring the information on the DNA, but it's interesting that we can actually quantify these things. What I'm interested to mention here is that more and more nowadays, at least in my country, we are being hostage of fake news and cognitive entities which are actually dysfunctional, very dysfunctional. And people cannot really see the difference between opinions and knowledge. So we need to deal with that. So it's not about finding the truth and the falsity, but knowing what to do when agents come with their opinions on a certain subject. So let me propose that actually, instead of making this identification that I did before of judgment configurations like assertion and denial with the true and the false, that from now on, I will consider these agents as being entities who will be able to entertain certain kinds of cognitive attitudes, which will be my new primitive objects, with respect to certain pieces of information. I need to explain what I mean by these attitudes. So I give some examples of what these attitudes could be. For us here, and I'm happy to go alongside the inferentialists in our talking about our practices and of giving and asking for reasons. This is older than Brandon, but it's now very, very much associated to him. Let me say that if in case the agent has reasons to accept certain thing, I will use the Y for yes. And in case the agent has reasons to reject a certain piece of information, then I will use N for no. And just to have the complements here for the canonical approach, they don't need to be the complements, but here they will be. I will use the Y upside down for non-accepting and the N upside down for non-rejecting. Now, I know it's a lot to remember, but what's important here is that instead of assertions and denials, I have acceptance and rejection. And I'm not assuming that either is the complement of the other. So acceptance and rejection might be totally independent cognitive attitudes. Of course, there is a problem there, is when we want to, we have several agents around or same agent in different moments of time, giving their opinions on something and they pass their judgments on something. We need to talk about aggregation. I will not enter very much into that, but that's obviously important independently of what I'm going to say here. And again, going back to how we are hostage to fake news nowadays, we should make an effort to neutralize bias as much as possible in doing this aggregation. But I will just use this Y and inverted Y, inverted N, and just for you to try to see that they can fit into a general picture. I do have a picture here which is not showing. Okay, yes. So you might want to put this into a certain sort of square of oppositions. And so you see here the yes, of course, and the N as no way. Now you might imagine that these two things can be can coexist in such a way that you would have something else happening there. These things would only be subcontrary forming operators. And so I will have here some no acceptance and non-acceptance being contradictory, and rejection and non-rejection as being contradictory. This is acceptance, non-acceptance, rejection, non-rejection. I will have a notion of opposition here in the horizontal, which I call actually antonymy, and we have a vertical notion of duality. I would not, this is totally separate talk that I had actually suggested instead of this one, so I will not enter very much into detail of this. Just wanted to show that these attitudes, they can be conjugated in a single picture. Let me show you something more, more practical. Now, I want to go into further dimensions. What do I mean by that? Well, let me make this analogy with flatland, in which you have these guys living here in line land, and they cannot actually understand the two-dimensional guys who just came by, because they can only see a section of them at every moment. So they only understand them as being segments of line instead of real two-dimensional objects. So I claim here that Tarski lives in lineland. The unilateralist approach is lineland. And I'm offering you to come with me to flatland. Of course, you will say that in the next step, you want to go into further dimensions, but well, my slides have only 2 dimensions, so I will stay at this moment here. Now, what do I mean by these dimensions? Well, the idea will be that one might want to consider a logic which contains more than one consequence relation. One very simple way, straightforward way of doing that was done by Schrank and Vanzing in their book, was to consider a new notion of logical matrix in which you have several different sets of designated values, and for each one such set, they associated a Tarskian consequence relation. That's simple. They don't need to have any relation at all with each other. So it's a very weakly connected set of consequence relations. What I want to consider here is not this, one thing which I claim to be a little bit more connected, a single notion of consequence which itself has more dimensions. And I will consider the case of 2 dimensions. So how come? Well, let me just recall to see if every one of us at the same moment. I have proposed to read the unilateralist approach to assertion and denial by saying that, well, delta 0 is compatible with delta 1 in this sense, if the sentences in delta 1 may be asserted while those in delta 0 are denied. And then from that, I defined, or I used the notion of logical matrix with a set of truth values and a set of designated values. And I used the designated values as a way of asserting, while the undesignated values were ways of denying. So this was the mapping that I did with the Sushko reduction. Asserting turned out to be connected to the truth, and denying turned out to be connected to the false. What I want to do now is to go one step further and consider 2 dimensions. Now, some people will say, now I don't understand what you're doing anymore. But wait, just wait a moment. Imagine that this first thing here, let me just write here. This is our dark triangle, and this is our empty or blank triangle. You remember that I started with a dark triangle for compatibility. What I'm doing here is just an extension of that notion of compatibility. It still has 2 sides. There is the left-hand side and there is the right-hand side. Only that now, each one of those sides has up and down. What do I mean by that? Well, you can just look here. This 1, 1, this set here, is here put together with acceptance. Yes. While 2, 1 is here put together with non-rejection. So let's just to read this. I say that all these 4 sets of formulas are compatible if one may assert these formulas, non-reject these ones, reject these ones, and non-accept those ones. Or if you prefer to look at the consequence version, which is the complement of that, you just say that this fails. Okay, so it's very similar to what we had before, only that there is now up and down. Okay, there is a left side, there is a right side, just like in the Tarskian T consequence or S consequence. Now, what I want to do with this is to consider a new notion of a logical matrix. And it's very simple to do that, I claim, because actually you just need to add 1 extra set of designated values. And I decided just to choose here Y as a symbol of the set of designated values, which I might equate with something which is analogous to the truth. And I used N here for another set. What's important for me here is that they are just subsets of V, and I claim nothing about them having an empty intersection, for instance, or covering the whole set V. And that's, you might imagine, where some further logical values will come from. Now, as we shall see, I've seen in the next slide, there will be some other logical values that will play a natural role here. Now, I do not claim to have been the first person to have thought about this. There is actually a much more general approach by Lord Humberstone to the same, what a surprise, to the same issue, in which actually he defines, instead of using two separate things as I did here, he defines a notion of consequence in between two different languages. And he uses one language to the left and one language to the right of the consequence relation. And because each one of those is bivalent, at the end you have 4 logical values. The way that I get 4 logical values here, I want to show, is very similar to what I have done before, and different from that the approach by Lloyd, and less general because I'm using a single language. But the thing is, if you start with a set of homomorphisms and then you use this new way of flattening the truth values by doing the following, which is in here, then you actually get the true, the false, but also 2 other logical values. How? Let me look at the picture here, which is easier to see. So how can I define the true? Before it was just being designated. Now, the true means being at the same time accepted and non-rejected. What about both, which is this new value here? Well, both will be being at the same time accepted and rejected. And the same things for the other values. So false is the intersection of these 2 things, and neither is the intersection of these 2 things. So primitive for me was the notion of attitudes, which is actually the edges and not the nodes of these bilattice. And the nodes of the bilattice were defined from the edges. Of course, you can do the other way around, but I claim that I can understand better, at least what's going on in terms of these attitudes. Now, just to be sure, why is it that now that we have a set of valuations which is not bivalent but 4-valent, not 2-valent but 4-valent? Because being true is equated with a judgment configuration which contains 2 kinds of judgment, acceptance and non-rejection, and so on for all of them. I just also illustrated this one. Gluts correspond to accepting and rejecting. It might just mean that you have reasons for accepting and reasons for rejecting. There are different reasons, or you have different agents bringing these reasons about, and they have also found different reasons. And one of them says and concludes that it's a certain piece of information is to be accepted, and the other one that is to be rejected. Okay, so now that I have hand-waved by saying that one actually needs 4 values, logical values, to talk about this, I go into the last set of slides in which I will consider particular logics. Now, the idea here is I have gone into this bilateralist approach and a full 2-dimensional notion of consequence. You might want your 1-dimensional notion of consequence back. I can give you back, and I can give you many others. In the literature, you not only have Tarskian consequence relations, but you also have Q consequence, P consequence, as proposed by people like Grzegorz Malinowski, Frankowski, and I claim that I can explain all of them in the same approach, in a uniform approach. Now, if you don't have your intuitions about compatibility yet, I will just rewrite them in terms of the complement, which is S consequence. And in terms of S consequence, I can just explain what it means to have something like preservation of truth or preservation of assertion, because it can be written in my framework as something that happens in this diagonal. So this diagonal contains what I call T statements, while this other diagonal contains F statements. And this other diagonal contains all the 2 kinds of statements, which I do not need to enter into much detail here unless you're interested. Now, if you still cannot recognize your logics there, just make them a single conclusion. And so the first two lines are going to change to something which is perhaps more easily recognizable. You have your notion of T or preservation of truth or T preservation happening here, and the notion of preservation of falsity happening here. Okay, in this diagonal. So if you think that the logic has all these things together, you might want to focus in only one of those aspects at every given moment. And we already do that. We have, for the one-dimensional case, the choice to focus only on the zero-dimensional case, which is focusing only on theorems or focusing only on anti-theorems. For instance, classical logic differs from intuitionistic logic on the set of theorems, but they have the same set of anti-theorems. Now, these two notions of consequence here do not bring anything really new because both are Tarskian, the first two bullets. The third and the fourth bullet, actually, they're not Tarskian. So they need some modification on the Tarskian axioms. And as I claimed, these modifications might be just by throwing away either axiom R or axiom T in any of the versions that we have seen before. This has also been studied by Lloyd Humberstone and other people in different approaches. We have proved in detail in using the Lindenbaum approach not 3 years ago that this is actually the case. Now, let me just go into this terminology. Some people sometimes talk about being credulous or being skeptical, or even more common nowadays, being tolerant versus being strict. Now, the usual canonical unilateralist approach in which I presented these two principles talks about assertions and denials. Now imagine that instead of assertions and denials, I substitute this for, say, acceptance and rejection. As I just mentioned here, acceptance is the Y and rejection is the N. Now, when I say that no sentence is to be simultaneously asserted and accepted and rejected, I can also in this framework represent this, but now instead of writing something in the diagonal, I would write something here in terms of certain kind of P statement. And the same thing about the principle of excluded middle. There are other versions of this principle which would naturally complement this principle over here in terms of compatibility. Each sentence is to be either non-rejected or non-accepted. I can change these things uniformly for accepted, for non-rejected, rejected for non-accepted, and so on. And these things here that I just represented will change. Things which are in the bottom will go to the top, things which are in the top go to the bottom, and there are different versions of the same principles. Now, I'll illustrate this, how this makes a difference, but I just wanted to mention that in this particular case, when I say that no sentence is to be simultaneously accepted and rejected, in terms of the Sushko reduction, this will result in forbidding one of those four logical values. So the value B will have no longer any use. So if you do the same reduction, it will result in the logic which is logically 3-valued in general. Might be even 2-valued if you're lucky enough. Now, there are many other things in the market, as I have mentioned, and you might recover a lot of them in this approach. For instance, the notion of Q consequence, which I have explained here in a generalized sense using set. Q consequence was only studied using set formula. They might be explained as a certain kind of logic in which you only use Q statements, but never T statements nor F statements. Or TS consequence, which could be explained by the work of Cobreros and David Ripley and many of Paul Legre, Robert Van Roy, when they talk about gluts being disallowed if they use only Q statements, which are the things on the top, and they go into set 4, then they have, I can recover their notion of consequence. They call TS consequence. ST consequence is the dual of it. It's simple to recover also. And the dual of Q consequence, which is P consequence, and so on. I'm not going to illustrate all this. I just wanted to say that this framework is very general and allows us to recover many things which are doing nowadays. Two more things I wanted to mention is, first of all, I mentioned negation at the beginning, paraconsistency and so on. Let me give you one slide on negation in particular. So consider a set of sentences or pair of sentences P and not P. There are a number of principles that are, or assumptions that I might make about those sentences. If we are in the standard Tarskian approach, and if acceptance is the complement of rejection, the three sentences that I just wrote here say the same thing. Saying that at least one of them is to be accepted is the same as saying that at most one of them is to be rejected once acceptance is the complement of rejection. Now, if it's not, then they might result in different principles. And we might also consider the duals of those principles. So at least becomes at most, and see what comes out of it. Now, if I want to represent this in terms of my present framework, it's interesting to notice that each one of them corresponds to a different axiomatic sequence. So if you just look at the left-hand side, these things here both have P and not P, or all of them have P and not P. On the right-hand side, you might read them as P or not P, while the things in this side have P conjunction, not P on the left. You might read all these things as variations on the principle of explosion, and all these things on the variations of the dual principle. So paraconsistent logic is particularly worried about this principle and not with the others. I wonder why. And I wonder why does anyone have ever considered these kind of problems? If you want to avoid this kind of sequence, you might have motivation to avoid them and create new classes of logics. I claim that people have not been doing this precisely because they have failed to separate acceptance from rejection and taking them as separate attitudes. So it's been difficult for them to see that these actually correspond to different things. So let me insist, both paraconsistent logic and paracomplete logic, intuitionistic-like logic, only worry about principle in bullet 1. Now for a final example, which goes beyond just this idea of verificationism and falsificationism, which are embedded in paracompleteness and paraconsistency. I wanted to do a logic with more connectives. So let me see what happens here if I start with a completely non-deterministic approach. What do I mean by that? Well, when I have as input any one of these 4 logical values, I can have as output anything, any one of the other values. So in the right-hand side here, inside these tables, I'm just considering sets of values. Now, I claimed at the beginning that my evaluations would be functions. So how come that when I have, say, F and N, I have as options 4 different values? Well, because in the non-deterministic semantics by Avram and other people, actually evaluation is a function that chooses non-deterministically any one of those values. So it's not that it takes all of them or that it relates F and N to all of those, is that you consider all the possibilities. Now you might say that this is a totally useful connective because it's so undeterministic that it doesn't say anything useful. So let me make it more deterministic then. Let me show you a procedure in which you can do exactly that. So instead of functionally associating the truth values to which you receive as input to those that you want to give as output, what I'm going to do is a different thing. Look at what happens here. I write this to say that some configurations are to be forbidden. Precisely those that I put here with a black, or in this case, a red square on top of them. So if I say that, well, one should not or cannot, for some reason, I assert that someone cannot at the same time non-accept alpha and reject not alpha, which is one of the principles on the previous slide, then some values from up there are immediately forbidden. And the same thing for other axiomatic sequence that I might write. So this other axiomatic sequence will forbid other values. and so on. If I write this for axiomatic sequence, you see that only one value is left as a possibility in each one of those lines. So now negation is a truth function. It didn't need to be. If I had stopped before adding all these four axiomatic sequence, it wouldn't be, but I went that far, so now it is. And if I want to do something with conjunction, I might just say similarly that when you cannot have alpha and beta at the same time accepted, while conjunction is not accepted. See what happens here? Acceptance means either T or B. Acceptance is neither T or B. So this is forbidden here, either F or N. Because if it would be the case, then this would fail. So for this not to fail, you have to disallow these values to avoid certain counter models. That's why I prefer the dual approach in which you look at the counter models instead of disallowing them. But anyway, this is interesting because it gives you a procedure for determining a truth table as much as you want. And you can write things like this and see what's going to happen. Now, what I wrote here in this 6 axiomatic sequence was a fully deterministic truth table, which is the truth table of conjunction in first-degree entailment. Now, if I look at this again, this is not exactly first-degree entailment because there is a difference. Well, not only it's expressed in set, but actually now I have assumed that I was working with a different notion of logical matrix. And these 4 values were not just truth values, they were logical values. So this is actually a new presentation in which first-degree entailment actually has a glut and has a gap. Now, what difference does it make? I just wanted to mention that, well, I can manipulate this easy as that. If I now want to disallow the value n, I can write a sequence that does just that, which is this one. This one says that, well, phi cannot at the same time be non-accepted and non-rejected and non-accepted. And this disallows the value n, so the n disappears from everywhere, and what you have there is LP. So you say, whoa, wait a moment. It's a 3-valued logic? Yes, but it actually has a logic. I recovered, reconstructed, vindicated the existence of dialetheis and LP by making them into real logical values. Let me just, before finishing this, and I know this is going to be a question, let me just write here so that you can see what I'm doing. What are these things about? So let me write this in terms of the one-dimensional approach. If I write this using only one dimension, I have to write both alpha and not alpha in the same line. So I have to flatten these 2 dimensions up and down and put them together. While if I write this all together, I have to write alpha and not alpha on the left altogether. So you might already be able to recognize here this second one as being a form of explosion or pseudoscotus, and this one as being a form of excluded middle for negation. So now the principles are principles concerning negation. While here again, you can probably see that all these things on the first column here are about conjunction introduction, and all these things here in these 4 columns are about conjunction elimination. So what is FDE? FDE is a logic containing 2 forms of exclude middle for negation, 2 forms of explosion for negation, 2 forms of conjunction introduction, 2 forms of each one of the conjunction eliminations. And the same for LP. The difference being that for LP, you also want to forbid the value n. And if you want to go to K3, of course, instead of doing that, you will write this phi down here, forbidding the value p. And if you do the 2 things at the same time, you're back to classical logic. And no use for B, no use for N. It's logically bivalent. Okay, just to finish now that if it was hard at the beginning to sell true contradictions or dialetheas, I wonder if from now on, if you look at the same logics in which these values actually are understood as logical values, and if you see that you could play with these truth tables as much as you want and not just stay on LP, but do whatever logic you want by writing the right sequence, is this easier to accept? Can we in particular sell this kind of dialetheas as reified by the logical value B to the logician on the street? Now, I haven't talked anything about the how we could allow a plurality of inferential mechanisms to cohabit. I just gave a hint on how this could be the case. As I said, you can have several dimensions. If this was not clear, feel free to ask me. Thank you very much for your attention.